Hi, I am Alekya Seerapu, and this is a walkthrough of my self-healing sentiment classification system, a LangGraph-based solution designed for reliable, confidence-aware predictions with graceful fallback handling. It all started by fine-tuning a DistilBERT model on a multi-class emotion dataset. The goal was to specialize the model for text sentiment classification across nuanced categories more than just positive or negative. This train model is saved and used inside the DAG's inference pipeline. Coming to the architecture, we didn't use LangGraph directly. Our architecture was inspired by LangChain's LangGraph DAG framework, a dynamic graph-based execution engine for building reactive workflows with state. The LangGraph DAG is composed of three key nodes. Inference node generates predictions using the fine-tuned model. Confidence check node evaluates confidence scores. If it drops below a threshold, it triggers fallback. Fallback node invites the user to clarify or alternatively uses a backup model if needed. The flow loops through these nodes until a final decision is made, either automatically or via user input. So the question is, what makes it self-healing? This classification pipeline incorporates a self healing mechanism that intelligently handles uncertain predictions by invoking user clarifications, thereby preventing incorrect automation. This thing is, the land graph DAG is composed of three key nodes. Confidence aware behavior. The confidence check node monitors the model's confidence score. If it is below the defined threshold, it automatically redirects to fallback instead of making a blind decision. Fallback with human in the loop. The fallback node dynamically engages the user to confirm or correct low confidence outputs, ensuring the final decision reflects human judgment when needed. Corrective recovery path. Every fallback interaction updates the final label and is logged, allowing the model to effectively heal from potential misclassifications. Point I'm trying to deliver here is the architecture lets the system route certain inputs down the recovery path instead of making risky guesses. Yes. So here I have a snapshot of the CLI flow. So how does it work? Let's see. The entire system runs through a clean CLI. When I input a sentence, the model predicts a label and shows its confidence. If confidence is low, it gracefully explains that fallback was triggered and politely asks me to select the right label, preserving both the control and transparency. This is where our pipeline heals itself. We can see confidence is 50%. So, what happens? If the model is less than 80% confident, as configured in, we have the threshold set as uh, zero point 0.8. Now, when the confidence goes below 80%, it avoids making a blind prediction. It asks the user to confirm a correct recording that is taken as a final decision. The log shows initial prediction, fallback trigger, and final label, all tracked systematically. So here we have confidence and fallback plots for our visual insights. We have the confidence plot. This is a CLI histogram of fallback frequency. And next, we have one more thing coming. Yeah, so we have this fallback histogram, which is a bar chart representing how often each sentiment class require fallback intervention. So these visualize how often fallbacks were triggered and which labels had more corrections. It's a quick snapshot of model behavior under uncertainty. Yeah. Here we have the training performance summary. Using DistilBERT, we fine-tuned on a subset of GoEmotions. Final validation accuracy was 75.2% and macro F1 was 74.99 with a training loss of 0.57. A decent performance given our time constraint. Zero shot backup model using Facebook BART large MNLI was implemented but could not be executed due to memory limits. Actually, I was working on Jarvis Lab where we are provided a quick instance and we had few memory limits on that. This fallback would have triggered if confidence was extremely low, that is less than 40%. The logic is in main backup model.py, the Python files are already shared, and fallback backup model, we have these for future uses. Let's walk through a live CLI demo of my self-healing classifier. So I have few examples up already, and you can quickly go through. Meanwhile, let us also type in something. Mm, So I'm saying sort of liked it, but not really sure. Let us see. Yeah. So the predicted label is positive. Confidence is 50%, which is low. So that's where the fallback kicks in. So it is prompting. Could you clarify your intent? Was this a positive review? It is not that positive. So I'll say no. Then it will prompt me to select manually. So what is the correct label? So it's a neutral statement. So yeah. So when I say two, so the final label is updated neutral and it is saying it is corrected by a user clarification. Okay. So let me say I loved it. So it's a clearly positive review and see predicted is positive and the confidence is 100%. Next I'm saying I hated it. So again, see, it is very clear. It is saying it is a negative label and it is accepting it confidently with a confidence of 99%. And similarly, we have other, I'm not that great over here, right? You can see this and there is a confidence 89%. So yeah, it is working pretty well. This is what we have for our beautiful project. To sum up, this is a confidence-aware, fine-tuned classification DAG that recovers intelligently, logs transparently, and interacts thoughtfully. All source code, logs, model, and this demo are included in the submission. Thank you so much for watching.